Okay, in this video, I show you how to use Microsoft Excel to solve normal probability problems. And what they tell you in the book is they says formulate the problem in terms of x values, calculate a z-score, a z-value, go to the back of the book, find the area under the curve, which will solve the problem. So before we do that, let me show you some things in Excel just as a reminder. Okay, so here's a normal distribution. You can see it looks like a bell-shaped, and right now it's centered at 12. I put the mean at 12 and the standard deviation at 3. Let's just change these numbers a little bit and see what happens. First of all, I'm going to make the mean smaller. I'm going to shift it this way. So if I make the standard deviation, the mean smaller, the distribution moves to the left. If I make it bigger, it shifts to the right. The other thing I can do is change the standard deviation. If I make it smaller, I get a very peaked distribution. If I make it wider, I get a broad distribution, more area in the tails. So what the area under the curve, the blue, is the probability. So an area under the curve is a probability, and it is the probability that you get a value at this value or less. So in this case, my value on the horizontal axis I said is 15. So 15 is about right there. So the area under the curve is a probability. So the probability that I'll get a number of 15 or less is this blue value, which is this number, 0.841. So 84% of the time, if I have a normal distribution centered at 12 with a standard deviation of 3, the probability that I will get 15 or less happens 84% of the time. That's the blue. The white, this side, then would be the probability of getting 15 or bigger, greater than 15, which is 1 minus that, or about 16%. This is the blue area, this is the white area, they total to 1. Now that's using Excel. Specifically, I'm using this formula in Excel, norm.dist. So let's show you how you do this using the back of the book. So what they say in the PowerPoint is to first of all calculate a z-score. So how do you calculate a z-score? Well, the formula for calculating a z-score is equal to the value, the x value, minus the mean, that's in the numerator, and the divide by the standard deviation. So if that's my x value, and that is my mean, and that's my standard deviation, this formula will calculate a z-score. It would be 15 minus 12, that's 3, all over 3 to get 1. So if I wanted to find the z-score of 16, you can see it gets bigger. If I wanted to find a z-score of 11, you can see it goes negative because it's 11 minus 12 in the numerator. That becomes a negative number. Okay, so there's my z-score. I'm going to put this back to 15. So here's my z-score, 1.0. Once you have your z-score, then go to the back of the table, to the table in the back of the book. I'll show you which one in just a minute, and find the area under the standard normal curve. So in the book, when you go to the book and you go to book contents, in matter, then go to table A3, cumulative areas under the standard normal curve, and it starts there. It has all the negative z's, and then it continues, and you can see it now has positive z's. So the area in the blue is the guts of this table. So we have to look up 1.00. So I go down on the z and I go down to 1.0, and then I cross that with this 0, and so this is the number I need, 0.8413. 0.8413. So the probability that I would have a value less than or equal to 15 is 0.8413. Well, doesn't that look familiar? That's what this is. And I didn't have to use the back of the book. I just plugged in and used the NormDist. So let's look at this formula. It always starts NormDist, and the first argument is your x value. That would be 15. The second argument is your mean, 12. Third argument, your standard deviation, and the last argument is always, always, always 1 when you're using the NormDist. Always put last arguments 1. And so you can go use the back of the book, or you can use Excel, which is what you're going to be required to do for some of the homework and test, and you get the same number. Let's do one more. What if I had a x value of 10? So I immediately see that the area to the left of 10 is 0.2525. Okay, now let's calculate the z-score for that. The z-score is equal to minus 0.667. That's 10 minus 12 in the numerator, in parentheses, divided by 3. So 10 minus 12 is minus 2, divided by 3 is minus 0.67. So I now go to the book, and I got to go to the negative side, and I go down here and I find minus 0.6. What I'm looking for is 7, something close to that. So minus 0.6, it's this column here, or this one of these two, So it's between 0.2546 and 0.2514. Probability that x is less than or equal to 10 is 0.2516, somewhere around there. Well, look at there. Look there, it was already solved for, and this is the more exact, because this one is just ballparking it between, we know it's somewhere between these two values, 0.2546, 0.2514. Well, if you use this exactly, you can find it is 0.2525. So that's how you need to use it, is to use the NormDist. What you need to do is definitely use the NormDist function in Excel. Okay, I'll put another video that talks about the standard normal curve. Thanks.